we were studying thermodynamics, and in the last video we studied how G gives free energy, gets changes with temperature and pressure. For this we got the equation something like this, and let's see how Gibbs free energy changes with pressure. For this we have to do a small derivation. So we know that G equals to H minus Ts. We also know that H equals to U plus Pv. And one more equation that we have studied here is du equals to dq minus pdv. So we are going to use all these equations to find a differential equation for del G. Let's see how. So G is nothing but H minus Ts. Let's take a differentiation right here. So dg will become dH minus tds minus s dt. Now let's take differential of H. So differential of H will be dH equals du plus pdv minus plus vdp, and du is already known to us. Let us substitute that inside. So substituting du inside, we get dH equals du is nothing but dq minus pdv plus pdv plus vdp. Pdv gets cancelled out. We get dH as dq plus vdp. Let's substitute back this dH and this dg equation. So dg will then become dH is nothing but dq plus vdp minus tds minus sdt. So we know that dq is related to entropy, and that is nothing but tds. We know this equation already when we studied about entropy. So this will get cancelled out, and what we finally get is this dg equals to vdp minus sdt. This is one more fundamental equation that we should remember. The equations that we should remember is these three and one this. So we should remember this, that dg equals vdp minus sdt, where dg is differential change in any reaction, and that differential change will depend on differential change in pressure and differential change in temperature. That's why we say that this G is dependent on pressure and temperature. That's the reason. So we can see that as the dP increases, this dG will increase. dP increases, dG will increase. We can see one thing. Now let's study a small topic which has a lot of examples, questions in exams. So that topic has many questions in any kind of exams, either it's JEE or GATE, any exam. So let's see what the topic is. So we studied this, and the topic which I was talking about is this Clausius Clapeyron equation. So you might know this equation, but you may not know the proof. So I'll show you how it's proved. So here we'll start with this point, that is this dg equals to vdp minus s dt. So we talked that, let's say there is a system or a material, anything, if it goes from one state to another state, so there is a phase change or change in state, and that is only possible if del G is negative. We all know that. Now let's say this is our state 1, this is our state 2, and we have this G for state 1 and G for state 2. Let's write del G for this state 1. So del G for state 1 will be nothing but this thing. V at state 1 del P at state 1 minus S1 dt1, and same will be dg state 2 V at state 2 dP minus S at state 2 dt. Well, there is no need to write 1 in this differential term because they are very small. So dP in this state and dP in this state are obviously the same thing. Now let's take at equilibrium. So at equilibrium we all know that this dg term goes to 0. So at equilibrium these both guys are 0, and if these are 0 we can equate this v1 dp minus s1 dt with this v2 dp minus s2 dt. Let's transpose this to that side. We'll get v2 minus v1 times dp and s2 minus s1 times dt. So we can see that dp by dt is nothing but del s by del v. So this is our basic Clausius Clapeyron equation. So I'll just write it down here. dp by dt is delta s by delta v. So this is our Clausius Clapeyron equation. But sometimes when you read the books, you will not find this equation. Rather, you will find the integrated form of the equation, and that integrated form has delta h. So once we know that this delta h by t is nothing but delta s, we can substitute that dp by dt is nothing but delta h by t times 1 by delta v. Now we got this temperature term and we can integrate. So you can integrate dp and delta h by t 1 by delta v dt. We can easily integrate these terms. We can find our answer. But I will not integrate. I will just show that this is our main Clausius Clapeyron equation. So now you can see with the rate of change of pressure will in fact change the volume and will change the entropy. And how it will impact the Gibbs free energy, which was our motto. We know that delta G equals to delta H minus T delta S. So we know how pressure change will impact this and how this will impact this. So I hope all these solutions will help you in any conceptual questions. So thank you for watching.